Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, this video is on the topic logical instructions in 8085 microprocessor. Here we will study the logical instructions like logical AND, logical OR, logical exclusive OR, NOT, compare and the rotate instructions which are available in the instruction set of 8085 microprocessor. So let us start with our topic. The logical instructions, they perform the logical operations like logical AND, logical OR, logical exclusive OR, NOT, compare, complement, rotate. All these instructions are, all these operations are performed by these instructions. So let us study one by one all the instructions which are available in the 8085 microprocessor. First instruction is the compare instruction and its mnemonic is CMP. So this instruction, it compares the contents of the register or the memory with the accumulator. Suppose we are comparing the contents of the register, so we will write CMPR. Okay, it can be any of the register like the A register, accumulator, B, C, D, E, H, L, any of the 6 registers of the 8085 microprocessor. If we are comparing the memory, then we are going to write CMP-M. Okay, and M is the address of the memory location which is there in the HL pair register. So it is going to compare the contents of the register and memory with the accumulator. Now how this comparison is done, suppose that if the contents of the accumulator and equal to the register or the memory, so if we perform the subtraction, like if we are subtracting the contents of the accumulator and the register or memory, then if they are equal, we will get the result as 0 because both the contents are equal, so their subtraction will result into a answer 0. Okay, so when we are getting a result after any arithmetic or logical operation as 0, then the 0 flag is set. Okay, so this comparison is done by performing the subtraction . Okay, and when subtraction is done, then we will see what is the effect on the 0 flag. So if the contents of the accumulator, they are less than the contents of the register or the memory, then carry flag is set. Means carry flag is equals to 1. If the contents of the accumulator are equal to the contents of the register and memory, then 0 flag is set. Okay, and if the contents of accumulator are greater than the register or the memory, then both the carry flag and the 0 flag, they are reset. Okay, because what we are doing, we are subtracting the register or memory contents from the accumulator. So if the if this is means this content is greater, then we have to take a carry, we have to borrow it. Okay, so carry flag will be set. In this case, carry flag will be reset because no borrow or carry is generated in that case, and zero flag is also reset because the contents are not equal to each other, result will not be zero. And when the contents are equal, because the result we will get as zero, we are performing the subtraction, so zero flag will be set. So we are going to check the contents. We will compare both the contents, means register with the accumulator and memory with the accumulator, and we will check the conditions of the flag. Carry flag and zero flag will be checked. If we found that the carry flag is set, then we can say that the contents of accumulator are less than the contents of the register or the memory. If we found that zero flag is set, then the contents are equal to each other. And if we found that the carry flag and zero flag both are reset, then the contents of accumulator are greater. So in this way, the comparison is done in the 8085 microprocessor using the instruction CMP. Okay. Next instruction is CPI. Okay, that means compare the immediate data with the accumulator. So because whenever I is written in any of the instruction of 8085, this I means immediate. Okay, so after this CPI, and 8-bit data is written in the instruction, and the contents of the accumulator and this 8-bit data, they are compared, because accumulator is also an 8-bit register. So both the 8-bit data will be compared with the contents of the accumulator, and again the same comparison is done by the subtraction, by performing the subtraction, and same conditions are checked here, that if the contents of the accumulator are less than the 8-bit data, then carry flag is set, zero flag is set, and if accumulator is greater than data, then carry and zero both are reset. Okay, so same comparison is done here, but in CMP we are comparing a register and memory with the accumulator. Here we are comparing an 8-bit data with the accumulator. Next instruction is logical and instruction, and for that we are having the mnemonic as ANA. So this is going to logical and the register or memory with the accumulator. So if it is ANA, then it is going to compare the register and memory with or it is going to logically add the contents of the register and memory with the accumulator. So if we are comparing register, we will write ANA and the register, that means A, B, C, D, E. It can be any of these register, B, C, D, E, H, L, any of the register we can use here. If we are logically adding the memory, then we will write M here. Okay. So it is going to logically add the contents of the accumulator and the contents of register or the memory location, and whatever will be the result, the effect of it will be shown in the flags. Like if carry is there or zero flag is affected, then we can check the conditions of these flags also. Next instruction is ANI. This instruction, it logically adds the contents of the accumulator with the 8-bit data which is given in the instruction itself. So it will be ANI, and then we will have an 8-bit data here. So this, because we are having I here, it means an immediate data is there. Okay, so 8-bit data and the accumulator, their contents will be ANDed with each other, and the result of that will be stored in the accumulator itself. The result of all the logical and the arithmetic operations, it will be stored in the accumulator itself. Okay, so here we are logically ANDing and the 8-bit data. Result is stored in the accumulator itself. And due to this instructions, all the flags are affected, like sign flag, zero flag, parity flag, carry flag, all the flags will be affected, or we can say modified due to this instruction. Next instruction is XRA. This instruction is going to exclusively OR the contents of the register or memory with the contents of the accumulator. And the result of this operation will be stored in the accumulator itself. So if we are writing XRAR, then it will be a register, and if we are writing XRAM, then it will be a memory location. Okay, and the address of that memory location will be we can get from the HL register pair, means the address to which the HL register pair is pointing, that will be the address of the memory location. Now due to this instruction, the flags S, Z, P, they are modified, and the carry and the auxiliary carry flag, they are reset. Okay. Now in the exclusive OR operation, we know that when we are having opposite values, like if we are having 0 and 1 and 1 and 0, then we will get a high on the output. Okay, when we are exclusively ORing the contents, then when we are having different values, different bits like 0 1 or 1 0, then we will get an high output, and if we are having same, then we will get a low output. So this is how the exclusive OR operation is performed. Similarly, if we are having next instruction as XRI, so this is also going to exclusively OR the contents of the accumulator with the 8-bit data, because here we are having I for the immediate, so XRI, and then we will have an 8-bit data over here. So here register and memory are exclusively ORed with accumulator, and here the 8-bit data will be the operand, is exclusive ORed with accumulator, and the result is stored in the accumulator itself, and all the flags, they are modified due to this operation. Now next instruction, next logical instruction is logical OR operation. We have studied logical AND, logical exclusive OR. Here now we are having logical OR, ORA. So it is going to logically OR the contents of the accumulator So if we are having ORA, then R, it will be a register, and ORA, if we are having M, then it will be a memory location. Again, result is stored in the accumulator itself, and all the flags are modified: S, Z, P, C, and auxiliary carry. Result of this operation is also stored in the accumulator itself, and similar to this we are having the other instruction, which is ORI, and here we will have an 8-bit data. Because I is there, so it will be for an immediate data which is given in the instruction itself. The operand is the 8-bit data, and it will be logically ORed with the contents of the accumulator. Result is again stored in the accumulator itself, and all the flags, they are modified due to this instruction. So these instructions are performing the logical operations like logical AND, logical OR, and logical exclusive OR. Then we have the rotate instructions also. They come under this logical instructions category, rotate operations. So the next logical instruction is rotate accumulator. So these are the rotate instructions, and the mnemonic for this is RLC. There is no operand in it, okay? Only we are going to write the mnemonic RLC in the program, and the operand, it is means it is implicit in the instruction itself. Means whenever we are writing RLC, it is going to rotate the contents of the accumulator to the left hand side by 1 bit, okay? So in this, each binary bit of the accumulator is rotated left by 1 position. So the accumulator, it is an 8-bit register. So all the bits, they will be rotated to the left hand side by 1 bit. So the D7 bit, it will now go into the D0 position. D0 is shifted to D1, D1 at D2, D2 is shifted to 1 bit left hand side D3, D3 will become D4, D4 will become D5, D5 will become D6, and D6 bit will become D7. So in this way, 1 bit will be shifted to the left hand side, and the D7 bit will become the D0 bit. So here the accumulator is rotated to the left hand side, okay? Now this D7 bit, when it is shifted to the D0 bit, it also goes to the carry flag. Okay, so carry flag is modified according to the bit number D7. If suppose bit number D7 it is 1, so carry flag will be set, because this D7 bit will goes to the carry flag also and to the D0 position also. Similarly, if the D7 bit, if it is 0, then the carry flag will be reset. So here, due to this RLC instruction, the carry flag is modified according to the bit number D7. The remaining flags S, Z, P and auxiliary carry, they are not affected. Okay, and because this instruction is not having any operand is implicit in it, so in the program if we are using this instruction we will just write the mnemonic RLC. Next instruction is RRC, that is rotate accumulator right. Mnemonic for this is, mnemonic means that how we are writing or using that instruction in the main program. What is the code for that? So rotate accumulator right, its mnemonic is RRC. Here also we are having no operand is implicit in it, and the operand is the accumulator. So the rotate operation, it has to be performed on the accumulator, and the contents of the accumulator are rotated to the right hand side by 1 bit position. So all the bits will be rotated or shifted to the right hand side by 1 bit position. So the bit number D0, it will now become the bit number D7. All the bits are rotated. So we are having the 8-bit accumulator. And this D0 bit, it becomes the D7 bit. D0 is the least significant bit and the D7, it is the most significant bit. So this LSB will now become the MSB. Okay, and also this bit is shifted to the carry flag. Okay, so this bit, it becomes the D7 bit also, and it goes in the carry flag also. So here also the carry flag is modified according to the bit number D0. If it is 0, carry flag will be reset. If it is 1, then carry flag will be set. Now all the other flags, sign, 0, parity and auxiliary carry, they are not affected. And when we are using this instruction, we will just write RRC in the main program. We are not going to specify any operand because operand is implicit in itself and the operand is the accumulator. And after this operation, the result will be stored in the accumulator itself because we are rotating the contents of the accumulator only. So the accumulator, it will be loaded with the new contents or new rotated contents which are shifted to the right hand side by 1 bit position. Next instruction is rotate accumulator left through carry. Mnemonic for this is RAL. No operand is there, operand is again the accumulator, and now we are going to rotate the contents of the accumulator to the left hand side, but here we are using the carry flag also. So here we are having RAL. Okay. So here rotation is done, but this rotation is done through the carry flag. Let's see how this operation is performed. Now all the bits have to be shifted to the left hand side by 1 bit position. So the bits are shifted to the left hand side, but now the D7 bit, it will be shifted to the carry flag, and carry flag will become the D0 bit. All the other bits, they will be shifted to the left hand side by 1 bit position. Okay, so in the earlier instruction, that is RLC, what we are doing, we are shifting all the bits to the left hand side by 1 bit position, and D7 was becoming the D0 bit, and also this D7 bit is going to the carry flag. But now a D7 bit will go to the carry flag, means here, and this carry flag, whatever will be the value of the carry, whether it is set or reset, means it's 0 or 1, it will become the D0 bit. So this carry flag, it is modified according to the D7 bit, just like the RLC. Okay, and the carry flag will now become the bit number D0. So this is the instruction: rotate accumulator left through carry RAL. Now all the other flags like sign, 0, parity and the auxiliary carry, they are not modified. Only the carry flag is affected due to this instruction. Next instruction is rotate accumulator right through carry. The mnemonic for this is RAR. No operand is there. Operand is the accumulator. So the contents of the accumulator, they will be rotated or shifted to the right hand side through the carry. So accumulator, it is an 8-bit register. So all the bits will be shifted to the right hand side by 1 bit position, but in the right hand side direction. So D0 bit, here we have to use the carry also. So the D0 bit, it will become the carry flag. Carry flag will become the D7 bit. So if we see here, we are having the 8-bit accumulator. All the bits have to be shifted to the right hand side by 1 bit position, but we have to use the carry flag. So D0 will become the carry flag and carry flag will become the D7 bit. And all the other bits, they will be shifted to the right hand side by 1 bit position. So this is the instruction RAR. Now here the carry flag, it is modified according to the bit number D0. Okay, and all the other flags like sign, 0, parity, auxiliary carry, they will not be affected. So these were the 4 rotate instruction: RAR, RLC and RAL and RRC. Okay. Next logical instructions we are having are the complement instructions. Complement accumulator. The mnemonic for this instruction is we have to complement the accumulator, so CMA. Now here also we will be having no operand because operand is specified in the instruction itself. It is implicit, that is the accumulator. So the contents of accumulator, they are complemented. Complement means that if the bit is 0, it will become 1, and if the bit is 1, it will become 0. Okay, complement of 0 is 0 and 1, they are complement of each other. Okay, so here each bit, or we can say the contents of accumulator, they are complemented. Suppose that accumulator, it is having the contents This is the content of the accumulator. Now when we are using this instruction complement the accumulator, that is CMA, the new contents of the accumulator are, instead of 1 will be complemented, it will become 0, 0 is complemented, it will become 1, 0 will become 1, 1 will become 0. So this is the new contents of the accumulator. Okay. Next instruction is complement carry. The mnemonic for this is CMC, and no operand is to be specified because here the operand is the carry flag. Okay, so whatever will be the contents of the carry flag, they will be complemented. Suppose if the carry flag is set, it will be reset, and if it is reset, it will be set. So if the carry flag is set, it will be reset. Set means its value is 1 and reset means its value will become 0. And if the carry flag is reset, it will be set. Means if it is 0, it will become 1. So we are having two instructions related to the complement operation, complement accumulator and complement the carry. Next instruction is set carry. Now the mnemonic for this is STC. No operand. Operand is the carry flag. Now this instruction, it sets the carry flag to 1. So whatever will be the value of the carry flag, it will now become 1. Means the carry flag will be set. And all the other flags like sign, 0, parity, auxiliary carry are not affected due to this instruction. Only the carry flag is affected. Okay, so the instructions we have studied like rotate instructions and complement and set carry instructions. These instructions do not affect the flags like sign, 0, parity and auxiliary carry. Only the carry flag which is associated with these instructions, only carry flag is affected. So in this video we studied about the logical instructions which are present in the instruction set of 8085 microprocessor. Under this category logical instructions, we studied the instructions logical AND, logical OR, logical exclusive OR, and then we studied the set carry, complement accumulator, rotate instructions. We studied 4 rotate instruction: rotate accumulator left, rotate accumulator right. We have used carry also there. So all the instructions under this category, logical instructions, we have studied in this video. So I hope that this topic is clear to you. Thank you.